So the default trait we've talked about before. The idea of default is that it's a trait for recovering C programmers. If you'll remember in C, the sort of traditional plan is that, if you declare global variables, the default value for everything is sort of 0, whatever 0 means, right? And in C++, we sort of extend that notion more. So if you declare a string variable globally, its default value is the empty string, and blah, blah, blah. In C, of course, the default value is the empty string too, because it's an array of zeros, and the first 0 is the null character that ends the string. And that Java kind of does some similar things where if you want, you can get default values for things. In Rust, there's no sort of standard default for things because you want to be able to have arbitrary things have default values. And so the way this was implemented is we just created a new trait in the standard library called default. And then we implemented default for all the standard types to say, oh, yeah, we got a default, right? The default for things like strings and vex is an empty one. The default for, for collections in general is an empty collection. The default for numbers is 0, and so forth and so on. And sometimes that's what you want. I sort of badmouth this in the notes I just edited up. It is a little bit error prone. What does it mean that 0 is the default number? Is that even a meaningful idea? I don't know. It's just a convenience, and you probably shouldn't use the default trait or implement the default trait, unless you are clear what you're doing, right? If I call something : default, I'm going to get a thing, right? If my struct derives default, then all the fields will be filled in with default values when I call the default method. Default constructor. Maybe that's cool. Maybe that's exactly what I wanted. Maybe it's not. It's up to me to keep track of what all that means. And when I impl default for my type, people are going to have to keep track of what my type's default is too to be able to use that effectively. And so I'm adding some complexity to the use of my type in exchange for some convenience. Is that even a thing? I guess it is. And so I think carefully before I add a default impl to my thing, but sometimes it's really handy and limited as it is. It's probably better to impl default than to provide a special no-name constructor function. And you could argue that things like vec : new should maybe have just been vec : default. Who knows? It's an interesting question whether what I just said is true. I mean, that's the real question is, should there be two ways to create sort of effectively the same object, vec : default, vec : new? In. Oh, borrow mute. There's a nice discussion in the book about borrow and borrow mute, which we could have an argument about whether they should exist for sure. The idea here is that we're going to have a restricted version of asref and asmute that applies only to types where sort of if you borrow it, you're guaranteed to get a thing that's sort of also a value. It's mostly for the collection types. So in particular, in a hash map in Rust wants to own its keys for obvious reasons. It wants to make sure the keys don't change under it and that kind of stuff. And yet, you don't necessarily want to take arbitrary types that you can have, references to, because some weird things can happen with stuff like ref cell and stuff that we haven't talked about yet. And so they defined this restricted types, the borrow and borrow mute types, which are sort of, well, yeah, not everything that implements asref implements borrow, but some of the things do. And it's the things that sort of when you borrow the value, you're borrowing the value and it can't change under you. And so, you can take a look at the book and see what's going on. There's actually a bug in the definition of borrow that's really super annoying, and hopefully you won't run into it with stir and string. We've also used from and into an awful lot, I think, already. These are the type conversion traits. I mean, it says not really needed, but, you know, needed is a relative term, I guess. Notice that into is just from with the types backwards. We just saw an example of that earlier in the class, right? Where it's like, well, do I want to be U64 : from T, or T, you know, T : into U64? Who cares? And if you implement from, you get a default implementation of into, like I said earlier. So mostly people implement from, unless there's a good reason not to. From and probably implementing into should get you an implementation of from as well. But it turns out the Rust language isn't sophisticated enough to make both of those work at the same time. It'll say, wait, this is not, you know. Now I've got an implementation of from and into and from, and oh, there's a loop here, and then it goes up. So we just broke the tie arbitrarily. From and into consume their arguments. That's something to watch out for. Is that what, you know, we didn't see it because we were converting to copy types, but you know, once you frommed a thing, the original is gone. And from has to succeed. There's no way for from to fail. By the way, it says in nightly, try from and try into are now in state stable as well, and give back a result or an option, I forget. So let's play with that a little bit, because that seems to be how things are going today. So that's absolutely legitimate because there's a from implementation for U64 from U16. And so if I run this, it's going to whine about unused variables, but it won't whine about anything else. Let's see some other examples. I can also say, that's legitimate because there's also a from implementation, right? So there's into implementation, so I can call dot into. There's also a from implementation. And obviously here I don't actually need to declare the type because the compiler can infer what I'm froming from. It's generally, you know, it's interesting there's the style question which you should use in a particular situation. But like I say, your argument will be consumed if let's just nimble from for a thing because that'll be fun. We'll make some struct types. And those types are pretty clearly not copy or clone because we didn't say they were. And let's impl from for one of these to the other. Impl from and then we say from S for T, and fun from takes, let's see, I think it moves it, so self returns self, and I can say, we'll just ignore our argument and return the struct T. There we go, because it doesn't matter, right? None of these have any things. So that's the way I can turn an S into a T. How exciting. So now I can write things like, and I can say let underbar y equals t going from S. That's a perfectly legitimate thing to do. And let underbar y equals S dot into, right?
Didn't S just get
Absolutely. So thank you for being one step ahead of me. That was my whole point. Was that, you know, there are both from and into implementations here because the into implementation is automatic if I have the from implementation. So this should be fine, except I just consumed S the first time, and now the second time, not so much. So let's run that. Oh, well, there's that. Let's just make it return a T. No. Oh. I'm not remembering how these things arguments work. That's how it works, I think, actually. So I actually it's passed as an argument. Use of move value S. Yay, that was the error that we were hoping to get. So here, when I go to call into, it's not like there's no into method. It's perfectly fine with that part. It's just like, you know what? You already consumed that thing. So I have to pick. If I do them in the other order, I'll get the same bug, just the other way around, right? If I do it this way, then it'll consume it in the into, and then the from won't be able to get it. And sure enough, from used here after the, yeah. All right. Let's talk about try from a little bit. So, like I say, try from is now unstable, and so I can, and try into, and so I can say, sorry. There we go. So I can actually say something like that. I'm going to take my integer number and try to turn it into an unsigned number. And in this case, and I'll get a type error here because try into returns an actual thing. It's like, you know what? Oh, well, it also wants you to use the trait. Because unlike from and into, it's not actually used by default. So there you are. Now I get mismatched types because try into returns a result, right? So I can unwrap here and get rid of the result type because I know this conversion is going to work and everybody will be perfectly happy. If I try into for -1 though, I'm not sure exactly how that's going to parse. That's interesting. I'm going to put parentheses around it for now. I'm really curious what will happen because I'm afraid that the thing will happen. Let's try it this way for starters. So now I expect the unwrap to fail and my program to crash at runtime because I can't turn a negative number. It's like, yeah. It's like, no. We panic now because you tried to unwrap unwrap a negative number. You tried to try from a negative number into an unsigned type. We don't know how to do that. Clear enough? So that's actually really super convenient, especially, working with numbers, but also working with almost any kind of type where the conversion might fail. I'm super curious now, is this going to be a compile time error because I negated the result of the try to, or is it going to be a runtime error because minus 1i18 is parsed properly? Various programming languages get this wrong. Let's see if these people got it wrong or right. Is the minus sign part of the constant? Say what? What does that mean? Oh yeah, so it does do it wrong. It's treating that as, it looks like I've got a constant there, which is minus 1i8. Nope. I've got the negation of an expression involving the constant 1i8. Thank you, Rust. Haskell gets this even worse, by the way, because there's no unary minus operator in Haskell, or it has the wrong precedence or something. This is gross. So watch out for that when you're typing Rust things. You would have thought that would do something more sensible. C got this right. It's one of the things that C got right and Rust just got wrong. So watch out for that. It's like, oh, I don't know how to minus this. I don't know what type you're trying to minus this into exactly, right? Because it figures, well, maybe the result of 1i18.try2.unwrap will be a negative number, and then I can negate it and get an unsigned number. Who knows what's going to happen, right? So there's that, which is nice. But if I do it this way, I'll just get a nice clean panic, which we probably should turn into some kind of error message. There we are. Because now the parsing is going to negate the 1i8 before it does it. Cool. O2-owned. So if a thing implements borrow, remember borrow is the funny version of asref that is restricted? Well, part of the reason it's restricted is so that you can have to-owned require that the thing be borrow. And anything that implements the to-owned trait, you can make sort of notionally the owned version of a thing from the unowned version of the thing. And so if I say hello.to-owned, it takes your ampersand stir, which is a borrow type, it turns out, and makes the corresponding owned type, which is string. And there are people in the Rust community who feel really, really super strongly that this is the right way to write that conversion, by the way. That .toString is just a primitive, terrible idea that what we really should be calling is to-owned, because the type's borrowed, and to-owned impls, maybe, I don't know. It's more useful in the general case where you don't know what to-owned type you want to mess with. It also works if you have a slice of stuff, you can turn it into a vec of those things. So you can take a slice and use all the slices implement to-owned by default, and so you can use the to-owned method to turn that slice into a vector. Make sense? And you'll see that around. The last thing in our garbage bag, which I'm going to talk about for completeness because it gets mentioned around a lot, is the cow type, the copy on write type. The cow type tries to capture this copy on write idea. So imagine that I have a stir reference, an ampersand stir, that I'm passing around to various things, and most things just want to read it. They don't want to modify it. And that's great, but then something wants to modify it. Well, if anything ever wants to modify it, with what we know so far, I'd have to pass a string instead, right? Because something someday was going to modify it, which means I pay the cost of converting to a string up front before I start passing the thing around. Yeah, but maybe the thing that's going to modify it never gets called. Maybe at runtime it turns out that I don't actually ever modify that thing. So now I've paid a string conversion cost, which is not a trivial cost for absolutely no reason. That's the motivation for the copy on write type. It doesn't work just for strs and strings. It works for any two-owned type, and it's sort of part of the reason for the existence of the two-owned type trait. What it says is, what happens is that the methods on cow let you do asref so that you can actually look at the value but not change it. They also let you do a store operation so that you can change the value. And if you go to do the store, asref mute or whatever on the thing, and it's not already an owned type, well, two-owned is called to turn it into an owned type. How does that all work? Well, we have an enum, and the enum looks like this. This is sort of where the journey of the last day or so or two has gotten us, is to where people are writing things like this. If you can wrap your head comfortably around this, you should feel like you have all the trait comfort you need. Let's walk through it really, really super slowly, just for the fun of walking through it slowly, right? We have an enum cow, and the enum cow has an associated lifetime, tick A, and then it takes a very special generic type, we'll call B, right? What properties does the generic type have? Well, first of all, questionably sized. Oh, remember questionably sized from a long time ago? It turns out we don't actually need the B to be sized for all of this to work, because the only thing we ever store of it is a reference to it, and references can be to unsized things. That's always okay. And so we say, no. For full generality, we'll say, no, B is questionably